Very good morning, friends. Myself, Professor M.H. Annaya, and in today's video, we are going to learn about the development of a square prism of the given dimensions when a circular hole of diameter is drilled perpendicular to the plane of the board. So friends, for the given question we have this square prism. It has a side 40 height 70, resting on HP with two of its adjacent sides equally inclined to VP, or all the four sides equally inclined to VP. So first of all, we'll write down the initial position, that is the front and top view of the prism for the given condition. So I just mark XY line here, which represents the line of intersection of HP and VP. And here friends, I mark a square of the given dimension. Say this is a square we have got. It has got a dimension of 40 mm. So each of these sides measure 40 millimeter. You can say 40 SQ or simply 40 here. So friends, all the sides are equally inclined. That is, this is at an angle of 45 degrees to the HP, and also this is at 45 degrees to HP. And we'll mark these corners as AA1, BB1, CC1 and DD1. It is a prism. We will locate the center of this and mark this as O comma O1. I'll simply say O here. Project all these and obtain the front view of this solid. Friend, this is how the prism looks in the front view. So we'll mark this as A dash, B dash, D dash, C dash, O dash, and this is O1 dash, and this is A1 dash, B1 dash, D1 dash, this is C1 dash. Friends, here a hole is drilled. The diameter of the hole is 30 mm, and that is drilled perpendicular to the plane of this board, that is like this, at the mid height. So friends, I am going to mark the mid height. The total height is 70 mm. That is the height of the prism, and we are going to mark the center point, that is this point, at a distance of 70 by 2, that is 35 millimeter from the base of the solid. And here we write a circle of the given diameter. The circle diameter is given to be how much? Diameter 30 millimeter. And this is a circle or the hole drilled in the plate. It has got a dimension of 30 millimeter dia. Friends, now we are required to find out the development. First of all, we will assume that this is not cut by any section plane, and hence in the development you are going to get four rectangles. Say this is one, number two, this is third, and one more. There will be four rectangles totally. This is how the development looks. That is, this has got a dimension of 40 millimeter. That is the side of each rectangle, and the total is 40 into 4, that is 160 mm. Now friends, here we have drilled the hole. I will show the presence of hole in the top view. So both the sides I will draw vertical lines to see what all it is cutting. So friends, I will start the development of this. Friends, say BB, because when you drill a hole, friend, I will show you practically how the hole is built. Friends, this is a prism, a square prism, and this is the lateral surface. There are four rectangles. That is 1, 2, 3 and 4 rectangles are there. Now I am keeping the solid in this position. So you will be able to see two rectangles in the front view, and a hole is drilled at the mid height of the solid, and this has got a diameter of 30 millimeter. So friends, when you just cut it on one of the edges and keep it open, you are going to get two ellipses, one here between first and second, and the second one on the other end. So let's see how to mark. Friends, I will start with this AB, and see, this is A, B, C, D, and this is again A. We have here A1, B1, C1, B1, and this is A1. So this is the development without the hole in it. And let's see where all it is cutting. Friends, this hole is drilled and it is cutting the vertical edges BB and DD. So BB is cut here. So I write a horizontal. So this is a point on that. And similarly DD, you will have one more point. Likewise friends, here the bottom is cutting same BB and DD. And very obviously friends, this diameter is equal to this dia. Again I am going to extend it till last and get this value. So these are the 2 points on the vertical edges BB and DD. Now friends, it is also cutting here this rectangle. What is the maximum distance? See here, when it is on the lateral surface, it's cutting lateral surface, you are going to have it as an ellipse after it is developed. So friends, I am going to mark this point on AB at this distance from A, on AB at this distance. Say maybe I am just marking the distance. I will take this distance as M, whatever may be the distance. It may be at the center or whatever it may be. So I am going to mark this distance M there and write a vertical line from there. And again similarly on BC at the same distance from C, I will take the same distance, and from this end, the point where it is cutting this surface, I am going to draw a horizontal line through that. So friend, this is the maximum or major diameter of the ellipse. This is the minor axis of the ellipse. The minor axis is equal to diameter of the circle, and the major axis depends on the diameter, and we have got the value. Friends, we have got 4 points here. So you can draw a curve passing through these 4 points, a smooth continuous curve. But what happens if you don't have points in between? The curve you get, that is the ellipse you get, may not be very smooth. So what I do, I would like to have some more points. So for that, I am going to take some point here. I just write a line at some angle, say 45 degrees here, 45 degrees, and obtain these points. So where do I get them? So it is cutting here. Let us mark where they are. So on AB, very close to B. On AB, we have got very close to B. Very close to B, you have got this point you have got. And similarly, you have to mark these points, same points on the other end. Friends, remember the distance whatever I have marked here is the same. So this major axis is equal to this major axis. This vertical height is equal to the diameter. So I have marked a point here, and from here I am going to write a horizontal line. I will repeat it again, friends. I have written a line at an angle of 40, any angle you can write down at 45 degrees. This is the point where it is cutting. From there, I am going to write a horizontal line and a vertical line. So this is the line through that I have got. And friends, I will tell you how to get the points there. So on AB, so this is cutting this near to B, you get a point here. So you get this point. Similarly on the other end also, at the same distance, you get this gap. So friends, this is one point, the second point, third, and this is the fourth point. And friends, you got here again from this point at the same distance from the center, you will have two more points because these 2 points are the same dimension. Similarly here, this will be the same distance maximum. This is on okay. You get a point here, a point here. This is the last point, friends. So friends, you have got totally 8 points. 2, 2, 4, 6 and 8 points. Draw a smooth curve passing through all these points. It should be a smooth continuous curve passing through all the 8 points. And friends, this is the ellipse you get on this surface. Similarly friends, you can take this measurement, mark here, same measurement. So the distance between these two is same. And similarly on the other end also you can just mark and extend this line. So mark these 2 points and again draw a smooth curve passing through all these 8 points. Friends, these are the two ellipses you see, and these two will be exactly identical. Now after obtaining these ellipses in the development, let us see what is the portion to be darkened. Friends, line AA and CC are intact, so I have to darken this AA at the other end. Then I have to darken this CC is not touching the hole, and then on BB and DD, only this portion is retained. Only this much is left over. So on BB and DD, I am going to mark this both at the top and the bottom. And friends, the full baseline, bottom line is intact. So I am going to show this by a full line, by a dark line, by a visible line. Similarly, the top face is also intact. The hole is not touching that. I will mark it by a full line. Friends, you have to darken only these borders. This vertical line portion up to here and here to be marked dark, and remaining all construction lines are to be retained. Friends, this is how we obtain the development of the square prism when it is resting on HP on its base with two of the base edges equally inclined to VP. So this is the whole drill, and when you cut it open and spread, you are going to get two ellipses symmetrically. These two ellipses will have the same dimension. Friends, similarly, you can think over a hexagonal prism. When it is positioned like this in the same way, you are going to get two ellipses. And if the surface is parallel to VP, one of the rectangular face parallel to VP, and if you are drilling a hole on that face, that appears as a circle, provided the diameter of the circle is lesser than the width or the side of that prism. Friends, I hope the presentation was interesting, and if you like this video completely, if you just go through this video completely, and if you like this, do share this video with all your friends. Thank you friends. Have a nice day.